as a reminder, I'm going to do this left-hand column with you, and you guys will, after I'm done, go work on these, and I'll come around and help you as need be, okay? So looking at, remember, these are not fun. Nobody likes doing these, not even me. I mean, I don't mind them, but it's not like my favorite math to do. It's just a necessary evil, okay? We've got to do it. We've got to know how to do it. So let's work on these together, okay? So remember, to add or subtract any type of fraction, these are called rational functions, we have to have a common denominator. So you know how I start these every time is I get set up for my new fractions, right? Because I can't add them the way they are here. And so I'm going to look at my numbers and then my letters. Let me back up for a second. If there was anything I could factor, I would do that first. But there's no factoring here. These are monomials, no pluses or minuses. So they both have an 8, so I know I'm going to have an 8 in my common denominator. Now, this guy over here has an x squared. This one doesn't have any, so we have to keep the x squared. And we have a y over here and no y. We'll keep the y. So that's our common denominator. Probably the hardest part is finding that, okay? Now remember, what we're saying here, in case you haven't caught on to it, we're saying we are not going to use these denominators anymore. We're changing them to what's in red. So if we're going to change what's written in black to what's red, if we're going to change those denominators, we have to change the numerators exactly the same way. So to go from 8 to 8x squared y, I'm multiplying by x squared y. That's what I'm doing to this denominator. If I do that to the denominator, I have to do it to the numerator. So I'm multiplying 3x times x squared y. Don't forget, when you multiply variables, you add their exponents. So I would get 3x to the third y. Okay?
Wait.
Yep.
So you're doing, you're not going to do 3 times x times y and x times y?
No, because there's no pluses, or it's not a distributive property because there's not a plus or minus. You're just multiplying everything together. So any numbers get multiplied together, there's just a 3. All your x's get multiplied together, and then there's just the y. Okay? And I'll try to remember that question when we get to one that does have that to remind you. All right, and then look, we didn't change this denominator at all, right? 8x squared y, they're matching exactly, so we don't change our numerator at all. And then your final answer would be one denominator of 8x squared y, and then just adding what's up top. And we can't actually add them together because they're unlike terms. And then that would be your final answer. Okay? I don't think I'm giving you any problems that, I mean, technically there are some problems where you could simplify it this step. I don't think I've given you any, or will I give you any. So I'll keep an eye on that, but I'm pretty sure I don't. All right, next one is subtraction. Just got to be on our toes with subtraction. We just have to remember some things can happen with subtraction that we have to be careful of, okay? So let's start just like we've always started, and then look at our denominators. So we have a 3 and a 6. What's the first common multiple, not factor, that 3 and 6 have in common? Blah, blah, blah. 6. Yeah, it's 6. All right, so we're going to use 6. So let me take back what I just said. If you use 12, you would still be able to do this problem, but you would have to simplify it in the end, okay? By finding the least common multiple, the smallest number they both go into, you shouldn't have to do any simplifying, okay? Then we have an x here, no x here. Let me say it differently. 1x for 0 x's, we will keep the bigger number, which is 1. We have 1y or 2 y's. We'll keep how many? 2. Always keep the bigger number with the letters. Because remember, you have to, well, let me not say that. All right, so we just changed our denominators, so we have to change our numerators. That's our next step. So from the first fraction's denominator to its new one, we have multiplied by y, right? 6xy times another y to get y squared. So we have to do that to the numerator. So that's 6xy. Okay? From the black to blue on the second fraction. I went from, I'm going from a 3 to a 6, that's multiplying by 2, right? It already has the y squared, but we're missing the x. So look, guys, I have to multiply my numerator by 2x, right? I'm going to go off over here to show you because it's kind of jammed in there. This is where you have to be careful. There's a negative right here. A negative, now it's a 2x times that numerator. Okay? Does everyone see where I'm getting that? That's the negative 2x times all of that. And this is where I'll use the distributive property. Do you see the difference, Dylan? There's a plus or a minus here. That's where I have to do the distributive property, okay? So negative 2x times 8x squared is negative 16x squared. What do I want to remember before I keep going? Does anybody remember? Right here, you want to do something so you don't forget. Yes, Dylan, very good. I'm going to change that to a positive because I basically just said I'm going to change this to a positive and just make the term in front of it negative. So I'm distributing a negative, but I don't keep that negative there. I already gave it to the 2x. Okay, that's confusing. That's going to be a problem area if we're not careful. And then negative times a negative is positive, and 2 times 4 is 8, and then x, y. There's a lot going on in that problem. But we're ready to write our final answer. So we're going to have 6xy squared on the bottom. Are there any like terms we can add? Yeah. 6 plus 8, because they have the same exact variables. They are like terms. Same variables, same powers. So 6 plus 8 is 14. And then minus 16x squared, because of the negative in front. And the order you wrote those numerators in really wouldn't matter. I kind of lied to you a second ago. I'm going to tell you this. On your quiz, I would accept this as your answer. Maybe if I gave you one like this, I might give extra credit if you simplified it. Okay? If you simplify this, what I want you to notice is that all of those numbers in front are divisible by 2. And they all have an x in common. So you really could simplify this down to 7y. We're going to cancel one of the x's. Divide that 16 by 2. Take away one of its x's. And then divide 6 by 2. And we took away its x. So I would accept either one on the quiz. I'll try to remember to put one on there on Friday, where you could earn extra credit if you simplified it. Okay. Number 5, looking at those denominators, there's still nothing I can factor. Okay. So I'm just going to go right to my creation of my new fractions. And I have one x plus 2 and no x plus 2s. So I'm going to keep an x plus 2. And I have one x plus 3 and no x plus 3s, so I'm going to keep an x plus 3. So again, the order you put these in your denominator doesn't matter, okay? Doesn't matter. So since I changed my denominators, I'm going to change my numerators. So in the first fraction, I multiplied it by x plus 3, right? So I'm going to multiply my numerator by x plus 3. Gosh, writing so small is not my thing. So, on a quiz, when you're trying to be really careful, make sure if you needed to write this bigger, like Erin and I, we write big. And this is a mistake waiting to happen for some people, right? Because you're trying to squeeze it in. That's why I came out to another space. So just be careful with that. Don't be afraid to write on the back or use another sheet of paper or something if it's going to help you do better. Okay, so here I'm going to distribute. That would be 6x squared plus 18x. Okay, I'm multiplying this guy by x plus 2. X plus 2, yeah. So I'm going to multiply the numerator by x plus 2. And it's positive here, so that makes us very happy. Whenever there's a plus here, we don't have to worry about that weird thing that happens. So I get 4x plus 8. And now we can combine any like terms in the numerator with our new common denominator of x plus 2, x plus 3. So I see I have an x squared. I have 2 x's and a constant. A constant is a number that has no variable. So let's just put our x squared first, right? We can add 18 and 4. And then that would leave us with the 8 at the end. Okay. Same thing with 7. Still no factoring. This is almost identical to number 5. Look at those two denominators. I need to have both of them represented in my denominator, my common denominator. I'm going to multiply my first numerator by b minus 6, right? And my second denominator by b minus 1. Whatever you're missing in the denominator, we just put it in there, so you have to put it in the numerator. Question? Did you guys have a question on this one? Did I lose you? Are you sure? Oh, no, you don't have to. It might not even be factorable. It's not factor. I mean, you could factor a 2 out. Would I mark it wrong? Is this what you're thinking? If you factored out a 2 and maybe made it this, that is perfectly fine. I'm not mad at that at all. It's a good thing to do, but it's not necessary. Okay? So I would not mark it wrong, but you don't have to do it to get it. Okay. All right. So I'm going to distribute 5b to b minus 6. So that's 5b squared minus 30b. Same thing here, 6 times b, 6 times negative 1. And put it all together under one denominator. I have a b squared, I'll put that guy first. I have negative 30b plus 6b is negative 24b, and then that constant at the end of minus 6. If you're working ahead, I'm going to have you get rid of number 4. You don't do number 4. Okay, number 9. Here's our first example, and then 11 is also another one where we have factoring we can do in our denominator. Okay, I can factor out a GCF out of here. If you can factor a denominator, not a numerator, if you can factor a denominator, you have to do that. Okay, so look what happens here. We have fraction minus a fraction. We have a 2 and we have a 3. What is their first common multiple? 6. Good. Remember, if you are getting stuck on that, make a list of their, not factors, their multiples. 1 times 2, 2 times 2, and so on. And see when you get to, the first one. Okay, so if you were struggling with how to find that number, you could use this little tactic. Okay, so that would be 6. They both would have a 6. And then this one has a k plus 2 and this one doesn't. So we're going to have a k plus 2. This problem has a minus in it, so we're going to be really careful to remember what we have to deal with in a second. Okay, so look at this factor here. What are we missing? What's missing in this factor that we would multiply by to get this factor? Times 3, right? If I multiply this denominator by 3, I would get this. So that's what I'm multiplying my numerator by. Good, Evan. So that's 15. So on the second one, it's multiply by 2, right, to get 6, and the k plus 2. So this one's a little tricky. I don't think we've seen one like this. So first of all, it's a negative, okay? I'm going to go over here and do it. It's a negative. And the 5 times the 2, let's just go ahead and make that a 10, and then distribute to the x plus 2. So I'm doing times 2 times x plus 2, or k plus 2, whatever the letter is. Sorry, it's a k. But, so I just went ahead and made the 5 and the 2 a 10. There's a negative in front. And when I distribute, I'm going to get negative 10x minus 20. Don't forget what? That would become a plus. So really, the moral of the story is, when you rewrite a minus over here, it's always going to get changed to a plus. You're going to give whatever you're multiplying by the negative, okay? So really, when you do this first step, that we'll do it again in number 11, you're always going to just make that a plus, okay? All right, and then final answer, we had a common denominator of 6, k plus 2, and combine any like terms. I'm going to put and the order doesn't matter. If you put the negative 5 first, that's fine, or the negative 10x, that's first, but I just got 15 minus 20 is negative 5. So there's another example, Sam, if you wanted to factor out a 5 or negative 5 in your numerator, it wouldn't be wrong. Okay. You don't want to, is that what you said? You don't want to do any more factoring than you have to, right? All right, last one I'm going to do with you right now is look at your denominators. There is factoring in the second one. That is a chart type of factoring, okay? So we have x plus 2 here, nothing I can do there. And I can factor this guy into the two numbers that multiply to get 12, add to get 8. So that would be 6 and 2. Any order, they're both positive, okay? So I'm going to go down. So I'm going to have my 2 new denominators. And remember what I said? This minus is always going to get switched to plus here. So if you want to go ahead and do that in that first step, that might be smart. And our common denominator, we have an x plus 2 and an x plus 2. We have 1 on each side, so we keep 1. We have an x plus 6 here and none there. We're going to keep an x plus 6. So everything you see in the denominators above are now represented in our denominators. So all I'm going to do to my denominator in my first fraction is multiply it by x plus 6. And there's nothing I need to do to this denominator. This denominator is perfect. And there's a minus 4x. Right? I gave the negative to whatever was in the numerator. And then the final answer, (6x plus negative 4x) is 2x plus 36. Is it getting easier? Even if you don't like it, is it getting easier each day?
Yeah, it's a bit easier.
A bit? Okay. I know, they're not easy. These are not easy problems. All right, so I'm going to put the answers up for the second half. You can cut number 4. They just take practice. Let me get back up to the top here. The order these numerators and denominators are in are not important. Okay? It's the sign in front of them that matters, not the order. Anybody wants to take a picture of it? Yeah.
Number 4, number 2, that is the 7 in the denominator.
No. We're going to keep any sign. Think of it as this. 5x over 7 is negative, the whole fraction, but there's only one negative, and we think of it, we always give it to the numerator. Okay?